Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Akmal bin Zuhaili and my matrix number is DE190203. So I'm a student from section 7 for the subject of Power Engineering Lab 1. Right now, I will show the simulation for my activity, which is activity 1. So as we can see, this is the circuit that has been designed in the multisim, and this circuit is known as a half-wave rectifier with R load. So the component that been used is one AC source, one diode, one resistor, and also one variable resistor. And the objective in this activity is to get the reading for the VAC, the Vout, the Vmax, and also the output current. So that's why we use multimeter across the AC source and also across the R1. And not to forget that we were asked to get the waveform for the V maximum and also for the output current, for the inverted output current, right? So this is current clamp, which very useful to obtain the waveform for the current. And the thing is, this current clamp has reverse prop direction, which we need to use in this case, as we want the inverted output current, right? So to have a look on the reading, which I will run the simulation. Okay, now the simulation is running, right? So the first multimeter will have the reading for the VAC, right? As we can see here, the value is 70.69 and it is set to AC, but we realize that the value is different here. We need to know that the multimeter read RMS, so that's why you get the value 70.69, while here is the peak, and we can convert from RMS to peak by using a formula, right? Alright, now the second multimeter will measure the output current. Alright, so if we can see here, it is set to DC, because we need to keep in mind that after the supply pass through the diode, the supply is convert from AC to DC. Okay, so meaning that this multimeter will be set to DC. Alright, so this is the value for the output current. So next, alright, so this is the value for the output voltage, and see, it's still in DC, right? And lastly is the Vmax. Alright, so for channel A is for the voltage, and channel B is for the inverter output current, right? And this is channel A, right? So we can see that the waveform for the voltage is in positive half cycle, while the waveform for the current is in negative half cycle. This is because the current has been inverted. Alright, in normal condition it will be in positive half cycle, but with the same shape. Alright, and as oscilloscope can measure the Vmax, we just need to move the tracer to the peak of the waveform, and we just need to read here channel A. We know that channel A is for the voltage, so this is the maximum voltage. Right, so that's all for activity 1.
My name is Amar Sofi Bezam Suri Arifin, matrix number AE190061. For exercise 1, activity 2, first we construct and arrange circuit as the instruction given, like this. This is an example for circuit 3, which consists of VAC, diode 1 and diode 2 parallel with each other. We connected with ammeter. After that, we connected it by series with inductor 1, inductor 2 and resistor, and also with variable resistor. For positive terminal of inductor at load, we connected it by positive terminal into oscilloscope, and for the negative terminal B, we connected it with variable resistor. For the VAC, we fix the value with this, like the instruction given, and after that we simulate it. So for the result, we get like this. This is the wave for oscilloscope, and after that, for circuit 1 and circuit 2, we rearrange the circuit, which is for circuit 1, the load just consists of inductor 1 and resistor without diode 2, while for circuit 2 consists of inductor 1, inductor 2, and resistor without diode 2. That's all.
Yeah, Assalamualaikum warahmatullahi wabarakatuh. My name is Zakir Shalibi bin Azim and my metric number is DE190184. And I'll be talking about the third activity, which is the bridge rectifier. Here we have our full circuit of the bridge rectifier. We have a VAC as our source, which is we put as 100 volt as the V peak. And we have 4 diode here as our bridge rectifier. A multimeter here to measure the current. Another multimeter here to measure the V output for our R load, which is 100 ohm. And our variable resistor, which is at 1 ohm. And we also have an oscilloscope to measure the Vmax of the R load. Next, let's see the measurement. Here we have the VAC is at 70.48 volt, and our current output is 61.285 milliampere, and our V output is 62.129 volt. Next, we will talk about the Vmax, which we obtain from the oscilloscope. Here in the channel A, we have a Vmax from the R load, which is 98.307 volt, which is the highest voltage capacity that the R load can take. And from the graph here, this is a sine graph and it's in the positive side because of the bridge rectifier converts AC to DC. Even in the VAC negative source part is in the positive part. Next is the channel B, which we have down here. This channel B resembles a sine wave as well. This represents the inverted current output that we obtain from the clamp that we reverse connected here. That'll be all from me. Thank you.